is f of 2. What does it mean? What is the question asking for, Kevin?
When x is 2.
Yeah, so anything in parentheses is x. Outside is y. So this is saying, there we go. If x is equal to 2, I need to find its corresponding y, because together they make an ordered pair. So Kevin, if x is equal to 2, f of 2 is equal to
-8.
-8. Or you could say y is equal to -8. Or you could say the ordered pair is 2, -8. So any way you want to notate that makes WSU an ordered pair. Alright, so the second one. Again, part of it is figuring out what the question is asking for. So if you look at the first one and try and compare it to the second, they're a little different. This one says approximate the values, if any, that where f of x equals 3. So f of x equals 3. What are you trying to find in this question? Dylan?
What x would be if y equals 3?
Yeah, so what is x if y is equal to 3? Because inside the parentheses this time is x, so we don't know x. But we know that the y value, what it's equal to, should be 3. Now this says approximate because there's not an ordered pair given to you that has a y value of 3. So you're going to have to approximate. Each one of these little tick marks is counting by 2. So this point here would be 2. In between would be 3. So if I go over to my graph, approximate the value. To me, here's 2, here's 4. It looks like that point is closer to -4 than it is to -2. Doesn't look like it's directly in the middle. But it's an educated guess, so estimate it. I said about -3.5. If you don't have exactly that, that's okay. If you said -3.75, if you said -3.25, because you're estimating where you think that value is. So the first one, you know x, you're finding y. The second one, they give you y, you're finding x. So the notation is similar, you're just missing a different piece. The third one uses the word zeros. So you have to remember what a 0 means. Emma, what does it mean if you're finding a 0? Yeah, so this time, if you're finding zeros, that means when is the function equal to 0? What's another word for a 0 that we used? Not a y-intercept, an x-intercept. So it's an x-intercept because f of x is 0 or the y is 0. So you're looking to see when is y 0 or when is f of x 0? Well, that has to be on the x-axis. So Emma, where are the values, the zeros, on the graph? Yeah, so -3, -1, and then 1. An x-intercept 0 is an ordered pair on your graph. It's a point, a location where it's crossing the x-axis. So those 3 questions pertain to actual points on the graph. The next 3 questions ask you to write answers as intervals. And for number 4, really I should have had that little extra s because there's intervals that satisfy this, not 1. So write the interval, or intervals, that satisfy where f of x is greater than 0. What is that asking you to find? Connor.
Where the graph increases and decreases.
So what do you mean when the graph increases or decreases?
Find the section of the graph that decreases and then the section that increases.
Are you in number 4 or number 5 and 6? So number 4, what does it mean if f of x is greater than 0? Yeah, so we want to find when y is greater than 0. Anytime you see f of x, it's y. Well, y is 0, we just said at those points. So any of these points is where we said y was 0. Which really means y is 0 on the x-axis. That's when y is equal to 0. So we want the pieces that are above 0. So if I have y equaling 0 and we need greater than, we need anything above. When you write it in an interval, remember interval really means that section moving left to right. So even though you're looking at the piece above the x-axis, you're describing the piece as it moves from left to right. So you're really thinking about the domain of that section. The direction said that this graph starts at -6 and ends at +7. So it doesn't go beyond what's pictured here. So kind of thinking about that in this interval here that is above the x-axis. Connor, do you think you can give me that interval that's above the x-axis?
Infinity to -3 parentheses.
So the -3, and he said negative infinity, but if I stop the graph at -6, we would say -6. What can we put around the -6, Connor?
A bracket.
A bracket, because the graph actually starts there. So I can put a bracket around that -6. And then there's another piece that is also greater than 0, and that's that little bump in the middle. Connor, what would that value be if I describe that distance?
-1 to 1 parentheses.
Perfect, -1 to 1. They get parentheses because we're looking at greater than 0, not equal to 0. So we know where it was 0, now we want everything above it. And again, you're describing that horizontal distance, left to right, space that it's taking up. The last two questions are asking where the graph is increasing or decreasing. So increasing, the graph should be moving up from left to right, decreasing, the graph should be moving down. Again, that horizontal distance, so really you're thinking about the domain of that piece. Mackenzie, how about one increasing part of the graph?
-2 to 0.
Yeah, so right here, -2 to 0. Both of those get parentheses because at that point, it either begins decreasing or it starts increasing. So you're going to put parentheses around there. How about another place, Mackenzie?
2 to 7.
Yeah, 2 to 7. So that piece on the far right. So at the x value of 2 to 7, we can put a bracket around 7 because the graph is done at that point. It doesn't curve back down, it just stops. So anytime the graph starts or stops, you can put a bracket. If it continues on and moves back down, that's when we put a parenthesis. Wait, and the last one says, where is it decreasing? So it must be the other places. Where else would it be or where is it decreasing?
I have bracket -6, -2 in parentheses, and you can in parentheses 0 to 2.
Good, nice job. So use that tonight, look over it again. Or draw yourself your own graph and then ask yourself the same questions. You're definitely going to see questions interpreting graphs. 2 sections, 1.3 and 1.4, we're just looking at graphs, interpreting graphs. Any questions on that? Alright, so then looking at your homework, this is the one I want. I want to talk about question number 6. Just trying to help some people out with number 7. The top 5 graphs were sent through, posted to Google Classroom and sent through Remind yesterday. But number 6 says, suppose you have this equation 3x minus 2, f of x. The function is equal to 3x minus 2. Write an equation for a different function g of x if the graph of g is obtained from the graph of f by the reflection. It is a little wordy, but essentially we have this original graph 3x minus 2 and we're going to reflect it either over the x-axis or over the y-axis. So we want to know what that new equation would look like. So you have to think, what does it mean if you have a reflection across the y-axis, and how would that affect the equation? So Kevin, what does it mean if you reflect something across the y-axis?
The x values will be opposite.
Yeah, the x values are opposite. So if I have a point in the first quadrant, over the y-axis, that same point is in the second quadrant at the same height, but the x value is negative. So when we took the notes, we said that that meant you have g of negative x. So in parentheses, if x is negative, You're reflecting it over the y-axis. So on the y-axis, it becomes negative, it's on the other side. But we need to create an equation for that, using the original one. So the original equation that you're given is 3x minus 2. So I'm going to take that original equation and literally make the x negative. Because that's what it means to reflect over the x-axis. And then simplify it. Like you typically wouldn't look at an equation and have in parentheses a negative x. So that actual equation for g would be negative 3x minus 2. So if my first equation was going through negative 2 with a positive slope, my second equation is still going through negative 2, but now it has a negative slope. And I can see that it's reflected across the y-axis.
Should there be parentheses around the negative 3x and once you simplify it, or?
No, you can keep it separate. You've applied the fact. Allie.
Why does the negative x become positive?
Because these guys here, you're just multiplying those together.
Okay.
So it still is, yes, in theory it's a negative, but you're like simplifying that to create your new equation. Other questions? So looking at the second one, it says reflected across the x-axis. So again, thinking about what that actually is doing, reflecting it across the x-axis. The y becomes negative. So that means my y, which is also g of x, because the function notation and the y variable are the same, becomes negative. How would I apply that to the equation?
Would you write negative 3 of x equals 3x minus 2?
And what do you have to do with that 3x minus 2? Oh, Dad?
Multiply by negative
Multiply by? Yeah, negative 1. Because that's what you're doing to get the equation to flip across the x-axis. You're taking the g of x, which is my whole equation, and making all of it negative. Again, you'll be asked to simplify that. So if I were to graph it, I would really be graphing negative 3x plus 2. So write an equation for g of x. My g of x function is now negative 3x plus 2. So here is my first equation, and then my second equation. And now you can see the x-axis, which is this guy here, has reflected. My line is reflected across the x-axis. So like graphically, you would literally graph that line, graph both of them. So questions? So are there other questions that you have? I was trying to walk around and answer some. I know we didn't get you guys over here, Maya.
7c.
My C isn't here. This one says reflected on the, yeah. So we have this graph, and you're reflecting it with the x-axis. Maya, what is that doing with your values? Making the y's negative. So if you take your current values and make the y's negative, you've reflected across the x-axis. So if this point is 2, 2, now it's 2, negative 2. This point here was 3, negative 1, so now it's 3, positive 1. And I'm going to have another one there as well. So if it was up, it's now down. The piece that was down has flipped up. Jake? Sure. Does that make sense? So reflecting it across the x-axis, make your y value. Other questions? So in your packet, there is a more thorough review worksheet that covers a more broad range of topics from the first half of this chapter. And it starts with something being a function versus it not being a function. Make sure you're able to recognize if it's a function and explain why or why not. The second group of problems on there are domain and range. If you choose to do them graphically, show a graph. You can think about them algebraically as well, but yes, you'll have your calculator tomorrow. And then there's some difference quotient. There's graphing a function and getting like the maximum in, the increasing and decreasing intervals. We talked way back at the beginning of the chapter, which seems like a while ago. We talked about slope, parallel, perpendicular, writing an equation for a parallel or perpendicular line, and all of that is also contained. The test tomorrow is 64 points. So essentially, the quizzes that you've had so far, the chapter P test and the one quiz, combine them together, and then you have a test. So a true test in this class. There's also a take-home portion of the test tomorrow. So you'll have a take-home part, and you'll have an in-class part. Ethan, you don't like that take-home part. You're like, no, forget it, let me just do it all in class. When you come in, I will ask you for your review. So if you could kindly take it out and staple it together either now or tonight, and I will exchange you for a test. Literally, as you're walking in, I'll have you stick your review on that table, and I'll give you the test so you can start it right away. So grab a partner. Please ask questions. Use the 20 minutes. This is a lot of time to get some things accomplished. Work with somebody. If you're in these, so that one was yesterday's. Yeah, and then the next one. And if your group did not turn in the word problem yesterday, please make sure you do that as well. Yeah. Okay, that's fine. You understand it? Yes. Okay. I was like, if you're not anyone.
Well, I thought this domain that wasn't the answer.
So this is one of the calculators in line.
Actually,
Did she say that?
I feel like she checks it, that's where everyone stops. You guys are too smart. You do this.
Oh, I just asked if you wanted to do it now to rip out the 2 pages of the second review worksheet and staple it together. So that means I'm going to have the y-axis.
Yeah, I really was like, how am I supposed to make this symmetric?
I see what you mean. So, okay, so you were on I was not even. So makes more sense.
Yes.
Yeah.
I was like, what is that? Yes, no, yes, yes, no, yes. But I just put gotcha. I want to slow like, okay, like, no. I put this song stuck in my head right
Let's just go to. As long as you're going to explain your mind. See?
now.